Hi everyone, in this video I'm going to solve Cambridge International AS and A-Level Mathematics Paper 2, Pure Mathematics 2 in a session February-March 2025, Paper 2-2. So let's start with the first question. Question number 1, solve the equation ln 3x plus 1 minus ln x minus 5 equals to ln 7. So all the three terms have ln. So we have to use a property of log. Ln is basically natural log. So ln of something minus ln of something. So use that property of log that when you have ln a minus ln b, that would be equals to ln a by b. And subtraction, when you have a subtraction sign, so these two arguments of log divide with each other. When you have addition, then they product with each other. Okay, so let me simplify. We need to solve this. Ln 3x plus 1 minus ln x minus 5 equals to ln 7. So here we can say ln 3x plus 1 over x minus 5, because we have a subtraction sign, equals ln 7. When we have a log on both sides, we can cancel the logs, right? And we are left with 3x plus 1 over x minus 5 equals to 7. Now here we can easily get the value for x. Cross multiply. 3x plus 1 is equals to 7 is multiplying with x minus 5. This term multiplied over here. 3x plus 1 stays the same. Now 7 times x is 7x. 7 times 5 is 35. So negative 35. Shift the x terms to the left side. 3x minus 7x. This is minus 35, and shift the constant on the right, minus 1. Plus 1 shift on the other side, minus 1. And 7x becomes minus 7x, right? Now from 7, when you take away 3, it's 4. It's negative 4x, and we have negative 36. Now to get the value for x, you have to divide both sides by negative 4. Negative is cancelled with negative, and 4 times 6, 4 times 9 is 36. 4 times 1 is 4, 4 times 9 is 36. From here, the value for x is equals to 9. So 9 is the solution. Question number 2. A curve passes through the point with the coordinate pi by 2 and 5, right? And is such that its first derivative is given to us. Find the equation of the curve, right? So we have given the first derivative dy over dx, that is equals to 4 secant square 1 by 2x. In order to get the equation of curve is basically find the value for y. So we have to integrate both sides with respect to dx. Okay. So dx and dx is cancelled out. Derivative is cancelled with this integral. We are just left with y equals to 4 is outside. Now integration of secant square is tangent. Use this formula, that integration of secant square x is tangent x, right? Now secant square is basically tan x, and x is basically half x. Multiply 1 over the derivative of 1 over 2x is just 1 by 2, plus some constant of integration, because this is indefinite integral. Now we are left with y is equals to 4 tangent half x, and 1 divides 1 by 2 is just 2 plus c, right? Y would be equals to 4 times 2 is 8 tangent half x plus c. Now to get the value of constant of integration, as we know that this would be the equation of curve, right? The curve passes through this point. So if the curve passes through this point, then this point must satisfy the curve. We use this point. X value is pi by 2 and the y value is 5. Just substitute this point and you will get the value for c. Y value is 5, 8, tangent x is 1 by 2, and the x is pi by 2 plus c. So 1 times pi is pi, 2 times 2 is 4, pi by 4. So we have 5 equals to 8. Tangent pi by 4 is 1, as we all know. But if you want to double check, this is in radians, right? Tangent pi by 4, which is 1. Okay. So we have 5 equals to 8. This is 1 plus c. So 5 minus 8, which is negative 3. This is your c value. Now we get the value for c. Just substitute over here and you will get the equation of curve. So the equation of the curve becomes y equals to 8 tangent 1 over 2x plus the constant of integration, which is negative 3. So that would be your equation of tangent. Sorry, the equation of the curve. Question number 3. The diagram shows the curves y equals to e power 2x and y equals to 8 e power minus x. Okay, so these two curves. The shaded region, this is a shaded region, is bounded by the two curves and the y-axis. This shaded region is bounded by the two curves and the y-axis. Okay, we have no idea that which curve is the top one and which one is the bottom one. Okay, so here we have some y value and here we have some y value where the x should be equals to 0. When you put x is equals to 0 in this equation, sorry, yeah, x equals to 0, e power 2 times 0 is 0, power 0 is just 1. So this value is 1. So it means this curve is e power 2x, right? And when you put 0, e power minus 0 or e power 0 is 1, so it's just 8. So here the y value is 8, this y value is 8, and here this y value is 1. So this curves tells you this is 8 e power minus x. Okay, now for part A, show that the x coordinate of the point of intersection of two curves is ln2. Point of intersection of two curves, it's x coordinate. We just need to solve. So here the x values are 0, and we need to figure out this x coordinate should be equals to, here we have 0 and here we have ln2. This should be ln2. Let me simplify. So the point of intersection of two curves, the first curve is e power 2x equals, the second curve is 8 e power minus x, right? Okay, let me take natural log on both sides. We can say, or yeah, it's better to simplify first. E power 2x divides e power minus x. This would be equals to 8. This term is multiplying with 8. So in order to get rid of it, divide on both sides, right? Now e power 2x product e power with x. When you shift this to the numerator, it becomes positive power. The sign of the power is reversed from negative to positive. This is 8. Okay, in the first step we have to get rid of this term, so divide both sides by e power minus x, right? In the second step you have to shift this to the numerator, so you have to reverse the power negative to positive. And in the third step, when the bases are same, we can add the powers 2x plus x. This is equals to 8, so e power 3x is equals to 8, right? Okay, or we can say e power 3x would be equals to 8 is basically 2 cube is 8, right? Now let me do the further simplification over here, right? Now we can say it applying ln on both sides. Apply natural log on both sides. Okay, so when we apply the natural log, so ln e power 3x, this is ln 2 power 3. So whenever we have a natural log or log, its property is first we have to shift the power before the log. Apply this property. So 3x ln e, and here we have 3 ln 2, right? Ln of e is always equals to 1. This is a standard one, that ln of e is always equals to 1. Use this. So 3x equals to 3 ln 2. So we can cancel the 3 on the both sides. This 3 with this 3 is cancelled out. Here we had just left with x is equals to ln 2. So it is proved that the x coordinate of the point of intersection of two curves is ln2. This is x coordinate, right? Now for part B, find the area of the shaded region. So as you can see, the area of the shaded region is bounded between the two curves, this curve and this curve, right? So when we have area between the two curves, we have to integrate the two curves with the limits from 0 to ln2, right? So the upper curve subtract the lower curve. So this one is the top curve. So the upper curve is 8 e power minus x and the bottom curve is e power 2x. So the upper one subtract the lower one from these two limits. So the shaded area becomes integration from 0 to ln2 of the upper curve. You guys can see this one is the upper one. This portion covered with the upper, which is e power minus 8 e power minus x dx. Subtract the integration from 0 to ln2, the lower curve. This one is the lower one, which is e power 2x. E power 2x. So you will get the area of the shaded region or area between the two curves, right? Use the formula of integration. 8 is a constant term. E power minus x integration is e power minus x divides the derivative of minus x is just minus 1. Limits are from 0 to ln2. Minus e power 2x integration is e power 2x divides the derivative of 2x is just 2, and the limits are from 0 to ln2, right? So here we have negative 8 e power minus x from 0 to ln2 and minus 1 by 2 and e power 2x from 0 to ln2. Now in the next step we have to apply the limits. You can see applying limits. So the upper limit subtract the lower limit. Let's see what is the value for the area. Negative 8 is outside. Minus 8 e power minus x is the upper limit ln2. Upper limit minus the lower limit is minus 8 e power minus 0. Upper limit subtract the lower limit. Minus is outside. 1 by 2 e power 2 ln2 is upper limit minus 1 by 2 e power 2 and 0 is the lower limit. Okay, let me simplify this further. The area becomes, okay, here we have to use a property of log that 8 is as it is. So this minus sign is before log, so it comes into the power e power ln 2 to the power negative 1 plus 8 e power 0 minus we have half e ln property. This any number which is multiplying before the ln, it comes into the power ln 2 and its power is 2 minus 1 over 2 e power 2 times 0 is 0, right? Further simplification, we can say area becomes negative 8 e and ln is just 1 and 2 to the power minus 1 plus 8 e power 0 is just 1. Anything to the power 0 is 1 minus this is 1 by 2. E and ln is 1, it's 2 power 2 minus 1 by 2 e power 0 is just 1. Okay, this becomes area is negative 8 multiply 1 by 2 plus 8 minus 1 over 2 multiply 2 square is 4 minus 1 by 2 times 1 is just 1 by 2. So now the area is 2 times 4 is 8 minus 4 plus 8 minus 2 times 2 is 4, 2 minus 1 by 2. Okay. 8 minus 4 is 4, and minus, what is 2 minus 1 by 2? 2 minus 1 by 2 is 3 by 2. This is 3 by 2. And 4 minus 3 by 2, 4 minus answer is 5 by 2. So 5 by 2 is the area. So shaded area becomes 5 by 2 square units. Question number 4. A curve has equation y equals to this for values of x such that x is between 0 to 2 pi. Okay. Part A, find dy over dx. So we have given y. So we have to differentiate both sides of the equation. So y differentiate to dy over dx. And here we have to use a quotient rule. This is in division. So the quotient rule is the denominator function and the derivative of the numerator function, d by dx of 4 sine x, minus the numerator function 4 sine x and the derivative of the denominator function, which is 3 plus cos 2x. Okay, this whole thing divides square of the denominator function. Okay, now dy over dx becomes 3 plus cos 2x is as it is. 4 is a constant number and sin x derivative is cos x. So 4 cos x minus 4 sin x is as it is. And here we have 3 is a constant, its derivative is 0, plus cos derivative is minus sin 2x and the derivative of 2x is 2, divides 3 plus cos 2x whole square. Further simplification, dy over dx is 3 cos 3 plus, sorry, 3 plus cos 2x, its product with 4 cos x, minus 4 sin x, its product with minus 2 sin x, sin 2x, sorry, everything divided by 3 plus cos 2x whole square. Let me do one more step. Dy over dx, this becomes 3 is multiplying 3 times 4 is 12 cos x and 4 cos x cos 2x plus 4 times 2 8 sin x and sin 2x, and this whole thing divides with 3 plus cos 2x whole square. Okay, so this is the derivative of the function in the simplified form, right? Now moving to part B, hence means use the answer from part A, find the coordinates. We need to figure out the coordinates, means the x and the y coordinates of the stationary points of the curve. Okay, so first thing first, we have given that for stationary points, we have to put the first derivative dy over dx equals to 0. So we have done with the first derivative in part A. This is a first derivative. We have to put this equals to 0. So here we can say 12 cos x plus 4 cos x into cos 2x plus 8 sin x into sin 2x divides 3 plus cos 2x whole square equals to 0. The first derivative equals to 0. Now when the denominator is cross multiplied with the 0, it becomes 0. and we are left with 12 cos x plus 4 cos x cos 2x plus 8 sin x and sin 2x equals to 0. Now with the help of this equation we can get the x coordinate, right? Now these here we have to use a double angle formula for the sine and for the cos. Okay, so let me use a double angle identity of sine and the cos. If I can write this down, that sine 2 theta is 2 sine theta cos theta, and cos 2 theta is 2 cos square theta minus 1. There are three identities for cos double angle. So it is better to convert everything into cos, right? Because this is in cos, 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 sine, and then sine. So majority are cos. So it is better to convert this expression into cos as well. Okay. So 12 cos x is as it is plus 4 cos x. Cos 2x becomes 2 cos square x minus 1 plus 8 sin x is as it is, and sin 2x is 2 sin x cos x equals to 0. Let me simplify it further. It becomes 12 cos x plus 4 times 2 8 cos into cos square is cos cube x minus 4 cos x plus 2 times 8 is 16 sin square x and cos x equals to 0. Now you can see everything is in cos except this sine. So you have to convert the sine into cos as well. We know that sine square theta is 1 minus cos square theta by using the identity that sine square x plus cos square x equals to 1. To get the value for sine, you have to say 1 and shift the cos on the other side, 1 minus cos, right? Now let me substitute the value. So 12 cos x is as it is plus 8 cos cube x minus 4 cos x plus 16 cos x is as it is, and sine square becomes 1 minus cos square x equals to 0. Now this is in cos, this is in cos, or it is better to open the bracket first. 12 cos x plus 8 cos cube x minus 4 cos x plus 16 cos x is multiplying with 1 and minus 16 cos cube x equals to 0, right? Now these two are terms in cube. These two are in cos cube. 8 and minus 16 are the coefficient of cos cube, which is negative 8. 8 minus 16, negative 8, right? 8 cos cube x minus 16 cos cube x minus 8 cos cube x. Cos is cos, cos, and cos. 12 minus 4 and 16. 12 minus 4 and 16. 24. 24 is a coefficient for cos x equals to 0, right? Now for this simplification, we can take 8 common. We can take cos x common. You're left with minus cos square x, and 8 times 3 is 24 equals to 0, right? Now we need to put both the factors separately equals to 0. So from here 8 cos x equals to 0, or we can say 3 minus cos square x equals to 0. So you have to say 8 never be equals to 0, cos x is equals to 0, and from here minus cos square x would be equals to 3 minus 3. Shift the 3 on the other side, becomes minus 3. Now here cos x equals to 0, we got this, and cancel the negative sign. So cos square x would be equals to 3, and to get the value for cos, taking the square root on both sides with the plus minus. So here we have cos x is equals to plus minus square root of 3 with a positive and negative, right? So what is root 3? Root 3 is 1.732. So here cos x is plus minus 1.732. So here we have no solution. Why we have no solution from here? Because the cos range is between 1 and minus 1. So it is 0, 0 lies in 1 and minus 1. We will get solution from here. But we have no solution from here. Why we have no solution? Because this is more than the range, 1.7. Because the range of cos is minus 1 is less than equals to cos theta is less than equals to 1. So cos should lies, value of cos should lies between 1 and minus 1. This is more. So that is why we have no solution, right? So we have solution from here, right? So we have the equation cos x is equals to 0. Now the first thing is to find the base angle. For the base angle, you have to say x would be equals to cos inverse of 0, and this is in radians, right? You guys can see the x values between 0 to 2 pi, they are in radians. Okay, so my calculator is in radian mode, right? So what is cos inverse of 0? Pi by 2. X is pi by 2. This is your base angle, right? Now here cos is positive, it's 0, so it's positive number. So between 0 to 2 pi we need to check that cos is positive in which quadrant, right? If I can draw the coordinate diagram and check, in first quadrant all trigonometric ratios are positive, sine is positive, tangent is positive, and cos is positive. Now from 0 to 2 pi, cos is positive in first and fourth quadrant. So first quadrant, the value of x is the base angle, and in the fourth quadrant, its value is 2 pi minus the base angle, right? Now we can say cos is positive in first quadrant. Now for the first quadrant, what is the value for theta? It's x use over here. X is equals to the base angle, which is pi by 2, and cos is also positive in the fourth quadrant. So what is the value for the angle x, which is 2 pi minus the base angle, which is pi by 2? 2 pi minus pi by 2 is, sorry, 2 pi minus pi by 2, 3 pi by 2. 3 pi by 2. So these are the two solutions for x. These are the two x coordinates, because we need to figure out the coordinates of the stationary point. We have done with the x values, we need to figure out the y values, right? So by substituting the x into your equation of curve to get the y values. So as you guys can see, this is equation of curve y equals to 4 sine x over 3 plus cos 2x. So here we can say for y coordinates, of stationary point, we need to put x values into the equation. Y equals to 4 sine x divides 3 plus cos 2x. Okay, now when y, the first is y equals to 4 sine x value is pi by 2 divides 3 plus cos 2 into pi by 2. Okay, sine pi by 2 multiply by 4, numerator is 4, divides 3 plus something. Okay, cos 2 pi by 2, negative 1. This is 4, and 3 minus 1 is 2. So 4 divides 2, which is equals to 2. So the y coordinate is 2. When x is pi by 2, y coordinate is 2. Now we need to solve the next one, right? So the y coordinate when x is 3 pi by 2. Okay, substitute everything. 4 sine 3 pi by 2 divides 3 plus cos 2 into 3 pi by 2. 2 and 2 is cancelled, just 3 pi is left, right? Sine 3 pi by 2 multiply by 4, it's negative 4 for the numerator. 3 plus cos 3 pi, negative 1. Negative 4 over 3 minus 1, negative 4 over 2, which is minus 2, right? 3 pi by 2 and minus 2. Now we can write down the coordinates of the stationary points. After that, we have to move over here that coordinates of stationary points are, when the x value is pi by 2, the y value is 2, pi by 2 and 2, and the other is 3 pi by 2 and negative 2. These are the only two coordinates of the stationary points. Question number 5, part A, sketch on the same diagram the graphs of y equals to absolute of 2x minus 3 and y equals to ln x plus 1. Okay, so first of all, let me show you guys the graph separately and then we have to draw on the same diagram, right? Okay, let me use a separate paper for this. So the first diagram, first function I'm going to use is y equals to absolute of 2x minus 3. How do we graph it out? We know that the absolute, when you remove the absolute, this is y would be equals to plus minus 2x minus 3. This implies we have two functions, y equals to 2x minus 3 and the other one is y equals to minus 2x minus 3. And this becomes y equals to negative 2x and plus 3. Okay, now we have to graph these two functions separately but on the same diagram, right? Okay, let me sketch this graph on the axis. So as you guys can see, this is in the slope intercept form, y equals to mx plus c form, right? Y equals to mx plus c. This is also in y equals to mx plus c. So c is the y-intercept, m is the slope, c is y-intercept, and m value is the slope, or we can say rise over run. Okay, so there are two ways to graph this straight line, these two straight lines, by finding the x and the y-intercepts, or you can say by the slope and the y-intercept method. Okay, so first thing we can see in this equation, the c value or the y-intercept is negative 3 and here the y-intercept is positive 3. So we need the y-axis 3 and positive 3. 0, 1, 2, 3. Negative 1, negative 2, negative 3. This is 0, 1, 2, 3, minus 1, minus 2, and minus 3. Okay. Now on the other side, we can label it to 1, 2, 3, minus 1, minus 2, minus 3. This is also 3, this is 2, this is 1, this is minus 1, minus 2, and minus 3. Okay, let me sketch this one. The first one is this equation, right? So we have the equation y equals to 2x minus 3. We know that the y-intercept for this equation is negative 3 and the slope for this equation is 2, which is rise over run. The y-intercept is negative 3, the slope is 2, which is rise over run, 2 by 1. We can write 2 as 2 by 1, right? Now the y-intercept is negative 3. This is your negative 3 y-intercept. You have to plot the y-intercept. Then you have to rise. Rise means up or down. and run means right or left, right? Rise is 2 units, so you have to move 2 units up over here, and the run is 1 unit, 1 unit to the right over here. So you need to connect these 2 points. 1 and -1 is the second point. This is the the first curve, right? Now for the second curve, we can say y equals to -2x plus 3. This is your second curve, right? Now here y-intercept is positive 3. This is 3. And the slope here we have is -2, which is rise over run. Rise over run. You can write -2 as -2 by 1. Now the slope, the y-intercept is 3. This is your y-intercept, 3. Now the slope is rise is -2, as I have told you that the rise is up or down, right? If it is negative, you have to move 2 units down. So 1 unit and 2 unit over here, and you have to run 1 unit right or left. It's positive, move to the right. So when you're moving to the right, this would be your second point. Let me connect these 2 points. Okay, so this is a graph for y equals to -2x plus 3, and this is y equals to 2x minus 3. Now, how do we graph the absolute function? As you can see, y is absolute of 2x minus 3. So we know that the absolute function is always on the positive y values, right? There are all the real numbers. The x values are all real numbers, 0, positive, negative, but the y values are not negative. Y's are always positive because absolute y is basically the absolute function. So absolute function is always positive, right? Now let me graph out graph of y equals to absolute of 2x minus 3. This would be, we can write this, draw it. Sorry. You guys can see. So they have some point of intersection. This is their point of intersection. This line between 1 and 2, I guess, because this is your x-intercept. This is the y-intercept, and the x-intercept is when you put the y, for x-intercept, y would be equals to 0, right? Now when y value is 0, what is your x? 2x minus 3 would be equals to 0, and x would be equals to 3 by 2. 3 by 2 is 1.5 in the middle of 1 and 2. This is 1.5. Okay. Let me label the number 3. We have 0, 1, 2, 3, this point, and we have to label 1.5. This is 1, this is 1.5, this is 2. So this is 1.5. Yes, this way and this way. This is how your sketch look like, right, for the absolute function. So we have done with the absolute function. Okay, now I'm going to explain you how do we graph this function y equals to ln of x plus 1, right? Okay, let me do it over here. The second function is y equals to ln x. This is the base function, right? And then some transformation applied on this base function, and you will get y equals to ln x plus 1, right? Okay, so this is the base function. So first thing, we need to figure out what is a graph of y equals to ln x, right? So as we know that when x is equals to 0, what is the y value? Y equals to ln of 0, which is infinity. It can be positive infinity and negative infinity both, right? And when y equals to 0, what is your x value? Y0 ln of x, right? Y0, and we have ln of x. Here we can take exponential on both sides, right? E to the power 0 equals to e to the power ln x. Okay, and here e to the power 0 is 1, e and ln is 1, we have x. So the x is 1. So the x-intercept is 0, infinity, and the y-intercept is, sorry, this is the y-intercept, right? And this would be the x-intercept 1 and 0. All right. Now let me graph this function. And for this function, as you can see, let me draw it first and then I will explain you guys what I'm trying to say. Okay, the y values can be positive infinity or negative infinity, right? And the here this x is 0 and the y is 0. When x value is 0, the y value is infinity, positive or negative, right? And when y value is 0, the x is 1. So x is 1 over here. This is x is equals to 1, right? X is 1. Now, the shape of the graph is like this or like this. We have no idea about that. As we know that this is your x-intercept, right? So this is how the graph look like, or we can say this is how the graph look like, because the y values can be positive infinity or the negative infinity, both, right? But we have no idea about the x values. As you can see, the base function is y equals to ln x. So what would be the x value to make this function possible? So the domain for this function is x should be greater than 0. When you put ln of 0, this is infinity. Ln of negative 1, negative 2, negative 3, and ln of 0 till the negative infinity, the values are not possible for this function. So more than 0, x is 1, 2, 3, 4, the values are positive. So the domain for this function is x is greater than 0. So y, we have already done with the y-intercept, x-intercept, which is 1. So this is how the graph look like. I hope this is clear now that why the shape is like this, not like the other way around, because the y values are the constant positive and negative infinity, but the shape is possible that it is on the other side, because when it is on the other side, when x is 0, minus 1, minus 2, minus 3, ln is not possible. Ln 0, ln minus 1, ln minus 2, log natural log of negative numbers does not exist. I hope this is clear now, right? Now this is for the base function we have done. Now the second function, the actual function, sorry, the we have given is y equals to ln x plus 1. So this is y equals to ln x plus 1. So what happened over here? So in this base function, what we have done, we have to shift 1 unit left. This is a horizontal translation. Horizontal translation. Anything add or subtract with the value of x. This is your horizontal translation. When it is add, then we have to move left. When it's subtract, we have to move to the right. So the whole graph shift 1 unit to the left. This point is 1, now over here. Okay, let me shift everything to the left and we can easily get the sketch. Okay, now this one shift to the left, it becomes at 0. Now the intercept is at 0, 0. This would be the 0, right? And the y values are same from positive to negative infinity. These are the y-axis, this is your x-axis, and this is how the graph look like. Yeah. Okay, now before you guys can see, we have a vertical asymptote for this base function x is equals to 0. X is equals to 0 is the vertical asymptote. Now for this function is x is equals to negative 1. X is equals to negative 1 is the vertical asymptote. Because for this, the x values should be greater than negative 1. All the x values are more than negative 1. Let's say this one is the line for negative 1. This is x is equals to -1, which is your vertical asymptote. Logarithmic function has a vertical asymptote and exponential function has horizontal asymptote, right? Now we have both the graphs. We need to sketch on the same diagram over here. Let me show you. You guys can see this is for the absolute function and this is for the logarithmic function. Let me sketch on the same axis. Okay. Right. Now we need to label it first. This is 0. For absolute function, we need 1, 1.5, 2. And this is x is equals to -1. And we need number 3. 1, 2, and 3. 3 is the y-intercept. 1.5 is your x-intercept for the absolute function. And x is equals to -1 is the vertical asymptote for the logarithmic function. This is your vertical asymptote, you guys can see, right? Vertical asymptote, and we have this would be the absolute function. Okay, and for the other one, logarithmic function, this is the logarithmic function. So this is a sketch for both. You guys can see I plotted the y-intercept. X-intercept is 3/2, or we can say 1.5. Okay, and this would be the exponential logarithmic one with the vertical asymptote -1. I hope this is clear. Now they have 2 points of intersection, you guys can see. Now moving to the second part, the x coordinates of the points where the graphs intersects are denoted by alpha and beta. Okay, now the x coordinate. These are the 2 points where the two graph meets or intersect, right? Their x coordinates, we can say this value is alpha and this value is beta, right? And we know that we have given that where alpha is less than beta, the alpha value is less than beta means the first value is alpha and the other one is beta. So they are trying to say that this point of intersection, the x coordinate is alpha. This is alpha. And for this point of intersection, the x coordinate is beta. And alpha should be less than beta, right? Now for part B, show that alpha is 1.5 minus 0.5 and then of alpha plus 1. So alpha is basically the point of intersection, right? So when this line intersect the curve, right? So what is the equation for this line? Okay, as I have told you, so this line is basically the blue one, the first line, the blue one. So for the blue one, we have used this equation, y equals to minus of 2x minus 3, this one. Okay. For the alpha, we have to use this equation. This equation is y equals to minus 2x plus 3. And the other one equation is y equals to 2x minus 3. And this log equation is given ln of x plus 1. Right. Okay. So we need to figure out the point alpha is basically the x coordinate or point of intersection of this and this. Both are in y. Sorry. What, right, this is y. Okay, let me figure out their point of intersection, right? So point of intersection of y equals to ln of x plus 1 and y equals to minus 2x plus 3, right? So both are in y's. We can compare it, compare the y values. Okay, so when we do the comparison of the y value, we can say minus 2x plus 3, this would be equals to ln of x plus 1. Okay, and as we know that the x coordinate, we can replace it by alpha, their point of intersection for this line, for this curve and for this curve, they have the x coordinate equals to alpha. So we have to replace it with alpha, right? Okay. Now this is 5b. Okay. Let x equals to alpha, right? When the x is alpha, then minus 2 alpha plus 3 would be equals to ln of alpha plus 1, right? And for this simplification, minus 2 alpha, this would be equals to ln of alpha plus 1, and shift the 3 on the other side, negative 3. Divide both sides by every term by minus 2, divided by minus 2, divided by minus 2. So alpha is equals to minus 1 over 2 ln of alpha plus 1 and plus 3 by 2. And we know that 1 by 2 is 0.5 and 3 by 2 is 1.5. So alpha is minus 0.5 ln of alpha plus 1 or plus 1.5, or we can say alpha is 1.5 minus 0.5 ln alpha plus 1. This is exactly the same. So we have proved that this would be the x coordinate of one of the point of intersection of the two curves, right? Now for part C, use an iterative formula based on the equation in part B. This is the equation in part B. We have to use iterative formula to find the value of alpha correct to 3 significant figure. Alpha should be in 3 significant figure, right? Okay, give the result of each iteration to 5 significant figures, right? So what would be the iterative formula over here? So the iterative formula is, so here we are dealing with the alpha, not with x, right? So we have to shift the alpha on the other side, and we can say the function f of alpha. This is a function of alpha, which is 1.5 minus 0.5 ln of alpha plus 1 minus alpha. This is alpha n plus 1, and this would be just n. In the subscript, you have to write n, and this is n plus 1. This would be the iterative formula for the function of alpha. 1.5 minus 0.5 and then of alpha plus 1 is same, just move the alpha on the other side. This is the whole function. Okay, so we need to figure out that this is iterative formula. This is a way to make an iterative formula, that the function of alpha, not the function of x this time. Okay, now to get the value of alpha, we need the initial guess. So how do we guess the initial value? Okay, as you can see, this point is 1, this point is 2, this point is 1.5, right? So as you can see, the alpha value from the graph, what is the value for alpha? It is not exactly 1, sorry, this is just a sketch, not the exact graph, right? So you guys can see the alpha value lies between 1 and 2, right? So you can we can fix the initial guess between 1 and 2, but before fixing it, we need to check whether there is a sign change between the number 1 and 2. Let's see. Okay, if the sign change occur between 1 and 2, then we can say that the value lies between 1 and 2. Okay, so let alpha is 1. So what is f of 1? And let alpha is 2, and what is f of 2? Okay, so f of 1 is 1.5 minus 0.5 ln of 1 plus 1 minus 1, and here 1.5 minus 0.5 ln of 2 plus 1 minus 2, because alpha value is 1 and alpha value is 2. Let me check. If the sign change occur between these two numbers, then we can say the root lies between them. Okay, right. 1.5 minus 0.5 ln of 1 plus 1 and minus 1 is outside. This is 0.15. Okay, and the other one is 1.5 minus 0.5 ln 2 plus 1 bracket minus 2. This is negative 1.15. 0.05. Okay, now you can see there is a sign change between the two numbers. So this means the root lies between alpha equals to 1 and alpha equals to 2. There must be a root between these two numbers. Okay, now we can easily set the initial guess. Now here we can say, since there is a sign change between x is equals to 1 and x is equals to 2, this implies root lies between 1 and 2. This implies the initial guess is alpha naught, which is, we can say, we need to pick the number between 1 and 2. We can take 1.1, 1.2, 1.3. So I would like to take 1.5, right? This is your choice, right? Now use the iterative formula. Iterative formula was f alpha subscript n plus 1. This would be equals to 1.5 minus 0.5 ln alpha n plus 1 minus alpha n. Okay, now use the initial guess, right? When n value 0, when n is equals to 0, what is your solution? F of alpha 0 plus 1, this is equals to 1.5 minus 0.5 ln of alpha 0 plus 1 minus alpha 0, or alpha naught we can say, and we have guessed that alpha naught is 1.5. So f of alpha 1 would be 1.5 minus 0.5 ln of 1.5 plus 1 minus 1.5. Okay, so we can say, and we know that for every iteration we have to give the answer up to 5 significant figures, right? 1.5 minus 0.5 ln of 1.5 plus 1 bracket minus 1.5. This answer up to 5 significant figures, 1, 2, 3, 4, 5. So it rounds to 5. Minus 0.4585. Okay, now the next one. All right, so now this iterative formula we have to use to find out the sign change for the initial guess, right? So we have to make this formula. So everything we have to shift on the left side and name it as a function of some x or some alpha. And we have to check that whether the sign change occur between the two values. So this formula we have to use for the sign change for the initial guess, right? Now the actual iterative formula which we have to use to find out the value of alpha is, now the iterative formula is the same that we have given, this one alpha, this is alpha n plus 1, and this would be equals to alpha n. Alpha n plus 1 would be equals to 1.5 minus 0.5 ln of alpha n plus 1. Okay, when n would be equals to 0, we have to use a value for alpha naught, right? When n equals to 0, so here we have alpha 0 plus 1 is alpha 1, which is 1.5 minus 0.5 ln of alpha 0 plus 1. And we know that alpha 0 is 1.5. So alpha 1 would be 1.5 minus 0.5 ln of 1.5 plus 1. Let's find out the first value for alpha. Okay, 1.5 minus 0.5 ln of 1.5 plus 1. So this is up to 5 significant figures, 1, 2, 3, 4, and 5. This round to 9. Okay, 1.0419. This is the first one. Okay, now for the next iteration we can say when n value is 1. So when n is 1 over here, so this would be alpha 1 plus 1 is 2, 1.5 minus 0.5 ln of alpha 1 plus 1. So what is alpha 1? Alpha 1 is this value. So 1.5 minus 0.5 ln of alpha 1. So here we have to just put the answer. This is 1.14. 1 2 3 4 1 2 3 4 5 till 5 significant figure, this would be 1. So this is 1.1431. Okay, now the next, when n value is 2, when n is equals to 2, we can figure out the next one, alpha 3. So this is 2 plus 1 is 3. 1.5 minus 0.5 ln of alpha 2 plus 1. This value is alpha 2. So replace it with the answer 1.1. 1.1188. So if I round it to 1 2 3 4 5 significant figures, 8 round to 9, 8 and this 9. Okay, let's make another iteration. When alpha is, n value is 3, when we put n equals to 3, we have alpha 4. 1.5 minus 0.5 ln of alpha 3 alpha 2 plus 1. Sorry, alpha 3. Yes. Alpha 3. I messed up. Again, alpha 3 is this value. So we have to replace this with answer, which is 1.124 and 6 if you round it. Okay. Now we need to figure out. Okay, let's make another iteration. When alpha is 4, n value is 4, we will get alpha 5. Alpha 5 is 1.5 minus 0.5 ln alpha 4 plus 1. This value is alpha 4. This is 1.1232. Okay, and we have to so on. Okay, so we have done 1 2 3 4 5 iterations, and after 5, and every iteration is up to 5 significant figure. After 5 iteration, we come to know that the alpha value should be in 3 significant figure. The value of alpha is, this is 1 point up to 3 significant figures, 1.04, 1.14, 1.12, 1.12, 1.12. So this is 1.12, right? So how I come to know up to 3 significant figures, up if you can say 1.04, this is not round up. 1.14, not round up. 1.1, so this round up to 2. 1.1.1, this round up, this is just 2 because not rounding up. 1.1 and just 2, not round up. So 1.12 is the value for alpha. Okay, so we can write this down that the value of alpha up to 3 significant figures is alpha is 1.12. So this would be the value for alpha. So the alpha is the root which lies between the number 1 and 2, and which is 1.12. Okay, there is very less space I have. All right. Now moving to part D, show by calculation that the beta lies between 2.055 and 2.065. Okay, so if the beta lies between these two numbers, it means we have to use a sign change. If the sign change occur between these two values, then we can say that the beta values lies between 2.055 and 2.065. Okay, so for beta, so what is the point of intersection? This curve and this curve, means this one and this one, they have a point of intersection, right? So for beta, we can say the point of intersection of the curve y equals to ln x plus 1, and we have the curve y equals to 2x minus 3. Okay, so let me compare the values of compare values of y, and here you will get ln of or we can say 2x minus 3 would be equals to ln of x plus 1, right? And we can replace x. What is the x coordinate for this? X coordinate is beta, right? Since x coordinate is beta, so replace x value with beta. So we can say 2 beta minus 3 would be equals to ln of beta plus 1, or 2 beta would be equals to ln of beta plus 1 and plus 3, or beta would be equals to 1 over 2 ln of beta plus 1 plus 3 by 2. So replace, divide everything by 2. So here the beta would be equals to 0 0.5 ln of beta plus 1 plus 1.5. Right. Now we have to make an iterative formula, this type of formula, and check whether the sign change happened between these two. Then we can say the value of the beta lies between these two numbers. So here we can say for sign change, to check the sign change, we have to use the formula that the function of beta would be equals to 1.5 plus 0 0.5 ln beta plus 1 minus beta. I just shift this beta on the other side, right? So if the value of beta lies between 2.055 and 2.065, then there must be a sign change. So what is f of 2.055 and what is f of 2.065? 1.5 plus 0 0.5 ln 2.055 plus 1 minus 2.055, or we can say 1.5 plus 0 0.5 ln 2.065 plus 1 minus 2.065. Okay, let's see the sign changes. 1.5 plus 0 0.5 ln 2.055 plus 1 bracket plus no minus 2.055. This is 3.39 times 10 to the power negative 3, and the other one is 65. 2.065, 2.065. This is negative 4.98 times 10 to the power negative 3. So as you can see, there is a sign change between two values, right? So here we can say, since sign change occur, this implies beta lies between 2.055 and 2.065. So it is proved. Question number 6, part A. Find the quotient and remainder when this number is expression is divided by this expression. Okay, the quotient and the remainder we need to figure out. Okay, let me divide it. So 3x minus 1, you have to divide 3x minus 1, and the expression is 18x cube minus 6x square minus 30x plus 4. We need to figure out the quotient. The term at the top would be the quotient and the remainder at the bottom, right? Okay, so 3x is multiplying with what number to gives you 3 times what is 18. 3 times 6 is 18. You have to multiply by 6. And x times what makes you x cube, x square. Okay. So if you can do 3x minus 1 with the 6x square, when you multiply, 6 times 3 is 18, x cube minus 6x square. So write it down, 18x cube minus 6x square. Okay, now we can subtract the two equations by changing the signs. So you need to change the signs, negative and this becomes positive. So positive negative is cancelled out, negative positive is cancelled out. We are just left with negative 30x and plus 4. Okay, so 3x makes minus 30x, so minus 10 if I multiply. So here you can see 3x minus 1 times by minus 10. 3 times 10 is minus 30x, and minus times minus is plus 10. Okay, so here we have minus 30x and plus 10. Okay, now the next step is to change the signs. Okay, it's plus and it's minus, so minus 30 and plus 30 is cancelled out, and 4 minus 10 is minus 6. So this is a quotient and this would be your remainder. Okay, so this expression is your quotient and negative 6 is the remainder. All right. Moving to part B, hence. Hence means use answer from part A. Find the integral, find the integration of this expression from 1 to 5. Give your answer in the form of A minus ln B, where A and B are integers. Okay. So we can say that we can write 18x cube minus 6x square minus 30x plus 4 divides 3x minus 1. We can write this expression answer, remainder, and divisor. The answer quotient. Quotient is 6x square minus 10. Remainder is negative 6. Divisor is 3x minus 1. We can write this as, right? Now, in order to integrate both sides, you need to integrate this expression with respect to dx. Okay, now this implies we have the integration of 1 to 5 6x square minus 10 minus 6 over 3x minus 1 dx. This integration we need to figure out. Okay, now here we have let me split this. 6 is a constant. Integration from 1 to 5 of x square dx minus 10 is a constant. Integration of 1 dx minus 6, sorry, minus 6 is a constant. Integration from 1 to 5, 1 to 5 of 1 over 3x minus 1 dx. Okay, here we have 6 x square. Integration is x cube over 3, and minus 10. 1 integration is x minus 6. 1 over x integration is ln x. So we have ln of 3x minus 1 multiply 1 over the derivative of this expression is just 3, right? And this limits is from 1 to 5. Okay, let me simplify this further. 3 times 1 is 3, 3 times 2 is 6. 3 times 1 is 3, 3 times 2 is 6. Okay, so we are left with 2x cube minus 10x minus 2 ln 3x minus 1. Now we can easily apply the limits from 1 to 5. The upper limit is 5, the lower limit is 1, right? Now we can say apply limits. Now applying limits gives you 2 times upper limit is 5 minus 10 into 5 minus 2 ln of 3 times 5 minus 1. This is your upper limit. Subtract the lower limit is 1. 2 minus 10 minus 2 ln of 3 minus 1. Because 1 cube is 1, this 10 times 1 is 10, 3 times 1 is 3, right? Further simplification, this would be 5 cube times by 2, 250. 5 times 10 is 50 minus 2 ln of 3 times 5 is 15 and minus 1 is 14, ln 14 minus 2 minus 10 minus 2 ln of 2. Okay, further simplification we have from 250 take away 50 would be 200 minus 2 ln 14. Okay, and minus we have negative 8, negative 2 ln 2. Right. Further simplification, 200 minus 2 ln 14. Open the bracket. Negative times negative is positive 8, and negative times negative is again positive 2 ln 2. Okay, so here we have 200 plus 8 minus 2 ln 14 plus 2 ln 2. Okay, 200 plus 8 is 208. That, let me take 2 common. Here we are left with ln 2 minus ln 14. 2 is common first, ln 2 and then ln 14. We need to find the answer in the form of a minus ln b. Okay, a and b should be integers. So this is 208 plus 2 is common. So here we use a property of natural log. When you have in subtraction, you can say 2 over 14. Okay, so here we have 208 plus 2. ln of 2 times 1 is 2, 2 times 7 is 14. Now 208 plus 2, and here we can write this down, ln 1 minus ln 7 in the division. Ln of 1 is 0, double check. Ln of 1, which is 0. Okay, so natural log of 1 is always equals to 0. So this is 208 plus 2. Here we have 0 minus ln 7. Okay, now we have 208 minus 2 ln 7, or we can say 208 minus ln 7 to the power 2. So any number which is before the natural log comes to the power. This is a power rule of natural log. 208 minus natural log of 7 times 7 is 49. Now this is in the form of a minus ln b. A is 208, which is integer. B is 49, which is an integer. A minus ln b. So this should be in the minus form. So that is the answer. Question number 7, part A. Express 6 sine theta minus 4 cos theta in the form r sine theta minus alpha. So here we have to use the difference formula for sine, right? Where r is greater than 0 and alpha is between 0 and 90 degree, find the exact value of r and the value of theta correct to 2 decimal place. Okay, so we need to express 6 sine theta minus 4 cos theta in the form r sine theta minus alpha. Okay, now we need to use a difference formula, sine a minus b. Sine a minus b, this would be equals to sine a cos b minus cos a sine b. Okay, let me open this formula and we can say 6 sine theta minus 4 cos theta. This would be equals to r sine theta cos alpha minus cos theta sine alpha. Okay, so here we need to figure out the value of r and the value of alpha, and r should be positive and alpha should lies between 0 and 90 degree. We need to find alpha up to 2 decimal place and r the exact value. Okay, so here we need to compare the coefficient of sine theta and cos theta, because we are not solving the values of theta, we are dealing with alphas, right? So here we can say compare the coefficients of, first is sine theta. So when you compare the coefficient of sine theta on both sides of the equality, so the sine theta coefficient is 6 over here, and on the other side the sine theta coefficient is r and cos alpha. This is your first equation. Okay, now compare the coefficient of cos theta. Cos theta is -4, and over here we have r cos theta is minus sine alpha. So here we can easily cancel the negative sign on both sides, and the second equation we got is 4 equals to r sine alpha. This is your second equation. And now with the help of these two equations, we can get the value for r and the value of alpha. Now, to get r, the first step is squaring and adding equation 1 and equation 2. Okay, we need to square and then add them up, right? So the square of this is r square cos square alpha plus r square sine square alpha. This would be equals to 6 square plus 4 square. Okay, let me take r square common. We are left with cos square alpha plus sine square alpha. 6 square is 36 and 4 square is 16, right? R square is as it is. Cos square theta plus sine square theta, this identity is just 1. And 36 and 16, 52. This is 52. So here r square is 52, but we need to solve for the value of r. So what we need to do, take the square root on both sides. And when we do the square root, this should be in plus minus. And root of 52 is 2 root 13. So the r value here, we will get r equals to plus minus 2 square root of 13, right? So here we have given that r should be greater than 0. So which value of r we have to choose? R is 2 square root of 13. The positive one we need to pick because r is greater than 0. This is the exact value for r we have done. Now we need to figure out the value of alpha, which is in between 0 degree to 90 degree. It is in degrees, right? Not in radians. And up to 2 decimal place. Okay. Now use the two equations again. Equation 1 and 2. If you divide equation 2 over equation 1. So here we can say dividing equation 2 over equation 1. Okay. Equation 2 is r sine alpha. Equation 1 is r cos alpha. Equation 2 is 4. Equation 1 is 6. Right. Here we can cancel the r. 2 times 2 is 4. 2 times 3 is 6. Sine alpha over cos alpha would be equals to 2 by 3. And we know that the ratio of sine and cos is tangent. Right. So we can name this as tangent of alpha. This is 7a. Tangent of alpha is 2 by 3. So what is the value for alpha, which is tangent inverse of 2 by 3? And it should be in degrees, right? Not in radians. My calculator is in degrees. Okay. Now tangent inverse 2 by 3. 33.69 up to 2 decimal place, right? So here we can say alpha is 33.690067 degrees. Since alpha should be for 2 decimal place, 2 decimal place, the alpha value is 33.69 degrees. And this value of alpha is between 0 and 90 degree. This value of alpha is between 0 degree is less than alpha is less than 90 degree. So this is a value for alpha up to 2 decimal place, and this is a value for r, the exact value for r. Now at the end we have to show that we need to express this in this form, right? So we need to express 6 sine theta minus 4 cos theta into r, which is 2 root 13 sine theta minus alpha, which is 33.69 degrees, right? This is how we need to express it. We need to show this expression as well. Now for part B, hence use answer from part A. Solve the equation this whole plus 5 equals to 0 is from 0 to 360 degree. As we know that 6 sine theta minus 4 cos theta. 6 sine theta minus 4 cos theta equals to this thing. Okay. So here we can say 6 sine theta minus 4 cos theta is 2 root 13 sine theta minus 33.69 degrees, and plus 5 would be equals to 0. Now we can just simplify. Here we can say sine of theta minus 33.69 degrees. This would be equals to, shift the 5 on the other side, it becomes negative 5, and divide this term, which is 2 root 13. Alright. Now this equation tells that sine of some theta is negative. Now from 0 to 360 degrees, sine is negative in which quadrant? Let me draw the coordinate diagram and check. Okay. In the first quadrant, all trigonometric ratios are positive. In second, sine is positive. In third, tangent is positive. In fourth, cos is positive. Now, sine is positive in the first quadrant and in the second quadrant. But in third and the fourth quadrant, sine is negative. So this is in degrees. So we can say 180 degree plus the base angle, and here 360 degree minus the base angle. This theta is the base angle, right? Base angle. Okay. Now, first thing is to figure out what is the base angle, right? So the base angle is theta minus 33.69 degrees. This would be equals to sine inverse of 5 by 2 root 13. Whenever we are dealing with the base angle, we are not considering the signs, right? It's not considering the negative one. This is in degrees. Your calculator is in degrees. Now, what is sine inverse 5 divides 2 root 13? So the base angle is 43.898 degrees. This is your base angle, right? All right. Now we know that sine is negative in which quadrant? Sine is negative in third quadrant and in the fourth quadrant. So what is the value for the third quadrant? So this whole angle, which is theta minus 33.69 degrees, this would be equals to 180 plus the base angle 180 degree, plus this is a base angle 43.898 degrees. Okay, 180 degree plus the base angle is this one, theta minus 33.69 degrees would be 223.89. And what is the value for theta? 223.89. You have to add 33.69 on the other side, plus 33.69, 257.58, or 257.6 degrees. This is a value for theta, and then this is in the range 0 to 360 degree. This is for the third quadrant, right? So we can say one solution is theta equals to 257.6 degrees. And sine is also negative in fourth quadrant. Now for the fourth quadrant, what is the value for the angle? So this is the whole angle, which is theta minus 33.69 degrees. This would be equals to, for the fourth quadrant, 360 minus the base angle. This is the base angle, 360 degree minus the base angle 43.898 degrees. Okay, so what is the value for theta? 360 minus 43.898 is 316.102 degrees, and then add, shift this term on the other side, 33.69, add 33.69, this would be 349 349.79 or 349.8 degrees. Theta is 349.8 degrees. This is also between 0 and 360. So these two are the values of theta. Now for part C, as the value of beta varies, find the greatest possible value of this expression and determine the smallest positive value of beta in degrees for which this greatest value occurs. Okay, so first let me rewrite this expression. As we know from part A that 6 sine theta minus 4 cos theta, this would be equals to 2 root 13 sine theta minus alpha, which is 33.69 degrees. Okay, now if we make a comparison, you guys can see if I can take 2 common. Yes, taking 2 common over here, we are left with 2 times 3 6 sine theta minus 2 cos theta, and taking 2 common from here we have root 13 sine theta minus alpha. Okay, now we can cancel the 2 on both sides, right? And then we have to replace theta, 3 sine theta minus 4 cos theta, replace theta by 4 beta. Let theta equals to 4 beta. When the theta value is 4 beta, we have 3 sine 4 beta minus 2 cos 4 beta. This is equals to root 13 sine 4 beta minus alpha. Okay, 3 sine 4 beta minus 4 cos 4 beta, take it square. Okay, this whole square equals to this term whole square, right? So we can say 3 sine 4 beta minus 2 cos 4 beta, its whole square would be equals to square root of 13 is just 13 sine square of 4 beta minus alpha. So just substitute this expression over here or just add 15, right? So 3 sine 4 beta minus 2 cos 4 beta whole square and add 15 on both sides. This would be equals to 13 sine square 4 beta minus alpha and plus 15. Now this expression is equivalent to this one, right? For this expression, the first thing is to find out the greatest possible value of this expression as the beta varies, right? The greatest possible value for this expression, okay? As we know that for the greatest possible value, this is 13 a constant, this is 15 a constant. The greatest value for this occur when we need to take the greatest value for sine, right? And the sign it lies between 1 and minus 1, right? For greatest value of 13 sine square of 4 beta minus alpha plus 15, we need to find the greatest value of sine square of theta. Let's say this would be theta. As we know that sine lies between minus 1 and plus 1, and sine square theta, this lies between 0 and 1. Sine is between 1 and minus 1 and its square is between 0 and minus 1. So what is the greatest value of sine square? Sine square greatest value is 1. So just put this equals to 1. We can say since the greatest value of sine square of something is 1. This implies 13 sine square 4 beta minus alpha plus 15. This would be equals to 13 into 1 plus 15, right? And then 13 times 1 is just 13, and 13 plus 15 is 5, plus 3 is 8, and 1 plus 1 is 2, it's 28. So 28 is the greatest value, right? This 28 is the greatest value. So we have done with the greatest value. Now the other part of the question says we need to determine the smallest possible. We need to first find the greatest possible value of this expression, right? And now we need to determine the smallest positive value of beta. Beta should be in degrees, right? The smallest positive value of beta for which the greatest value occur. At what point this greatest value? So the greatest value occur when the sine square is 1, right? So we need to figure out that value for beta, the smallest positive value. Now here we can say that the greatest value occurs at sine square of 4 beta minus alpha is equals to 1. At this point, the greatest value occur. Now we have to solve for beta. Okay, so when we have sine square of 4 beta minus alpha, this is equals to 1. Now to get the value for beta, we need to take a square root on both sides, which is plus and minus, right? Now cancel it. We can say sine 4 beta minus alpha is plus minus 1. All right. As we need to find the smallest positive value of beta, not the negative one. So we can say for positive value of beta, we have to consider this positive one, right? Not with the negative one. Sine of 4 beta minus alpha is 1. And what is 4 beta minus alpha, which is sine inverse of 1? What is sine inverse of 1 in degrees? Sine inverse 1, 90 degrees. So 4 beta is minus alpha is 90 degrees. 4 beta would be equals to 90 degree plus alpha. What is alpha? Alpha is 33.69 degrees. I'm writing this for the students who get confused at what is the value of alpha. Now beta would be equals to in 90 add 33.69. This is 123.69 degrees and divided by 4. 30.922. 30.9225. We need to find the greatest possible value of beta in terms of degrees, right? So that value of beta is 30.9 degrees. This is a great smallest positive value for beta at which the greatest possible value occurs. Question number 8. A curve has equation. This is the equation of the curve. Show that the first derivative is this. So we have to differentiate with respect to x, right? So differentiate with respect to x. Okay. So when we differentiate with respect to x, we have 3 is a constant term, applying the product rule over here, right? The first function is as it is, d by dx of the second function, plus the second function is as it is, d by dx of the first function, which is e to the power 2x. Plus 4 is as it is, take the derivative of d by dx of e to the power 3x, plus d by dx of y cube, and derivative of 18 is just 0, is a constant, and the derivative of constants are 0. Here we have 3 e to the power 2x dy over dx plus y e to the power 2x, derivative is e to the power 2x, and the derivative of 2x is just 2, plus 4 e to the power 3x, and the derivative of 3x is just 3, plus 3y square. The derivative of y cube is 3. First take the power, which is 3. The function is y and its power minus 1. 3 minus 1 is square, and d by dx of y equals to 0, right? Further simplification, we have 3 e to the power 2x dy over dx, plus 3 times 2 is 6 y e to the power 2x, plus 12 e to the power 3x, plus 3y square dy over dx equals to 0. Let me take 3 common, because throughout the equation 3, 12, 6, 3, all the multiples of 3, right? Let me take 3 common. So when 3 is common, e to the power 2x dy over dx, 3 times 2 is 6, 3 times 4 is 12, and y square dy over dx equals to 0. Now divide this 3 on the other side, it becomes 0. Now e to the power 2x dy over dx plus y square dy over dx plus 2y e to the power 2x plus 4 e to the power 3x would be equals to 0. Now let me take dy by dx common. Okay, e to the power 2x plus y square, these are the coefficients of dy over dx, and shift the rest of the terms on the other side. Minus 2y e to the power 2x minus 4 e to the power 3x. This becomes negative and this is also negative. Now to get the value of dy by dx, we can divide it. Minus 2y e to the power 2x minus 4 e to the power 3x divides e to the power 2x plus y square. So we have to prove that its derivative is exactly the same. Now that is the expression. Now for part B, show that the curve has no stationary points. Okay, we need to show that, right? So we can say for stationary points, we need to put the derivative dy over dx equals to 0. And we have done dy by dx in part A. This is your first derivative. Put this equals to 0. Minus 2y e to the power 2x minus 4 e to the power 3x divides e to the power 2x plus y square. This would be equals to 0. Now the denominator expression cross multiplied with 0, this is would be 0, and we are left with minus 2y e to the power 2x minus 4 e to the power 3x. This would be equals to 0, right? Or we can say minus 2y e to the power 2x would be equals to 4 e to the power 3x. Okay, and minus y, this would be equals to 4 e to the power 3x divides minus 2 e to the power 2x. Now it's plus y, right? Just left y over here. Minus 2 e to the power 2x, it divide on the other side. So y would be equals to 2 times 2 is 4 e to the power x. 2 times 1 is 2, 2 times 2 is 4, and here e to the power 3 and e to the power 2. So this 2 and the 2 power is left, just 1 x power is left, cancelled out, and 1 x power is left, or e to the power 3x over, and shift to the numerator, e to the power minus 2x. 3x minus 2x becomes 1x, right? Now this is your y. These are the y coordinates of the stationary point. Let me plug this into the equation, right? Put y in equation of curve. So the equation of curve is 3 e to the power 2x y plus 4 e to the power 3x plus y cube equals to 18. All right. Okay, 3 e to the power 2x, y value is minus 2 e to the power x, plus 4 e to the power 3x, y cube is minus 2 e to the power x whole cube would be equals to 18. 3 times 2 minus 6 e to the power 2x and x would be 3x, plus 4 e to the power 3x, minus cube is minus 2 cube is 8 e to the power 3x cube is 3x equals to 18. Now everything is with e to the power 3x. Now minus 6 plus 4 and minus 8. Minus 6 plus 4 minus 8. This becomes negative 10. Negative 10 e to the power 3x would be equals to 18. Let me solve for the x coordinate from here. If there is some x coordinate, okay. So e to the power 3x would be equals to 18 over negative 10. So e to the power 3x would be equals to minus 1.8. 18 over 10. 1.8, right? Okay. Now, exponential of negative does not exist, or we can take natural log on both sides, right? Take ln on both sides. To solve for x, we have to take natural log on both sides to get rid of this e, right? Okay, so natural log e to the power 3x is equals to natural log of negative number does not exist. So power comes before the log 3x, natural log of e, natural log of minus 1.8. Natural log of e is just 1, so 3x would be equals to natural log of minus 1.8. So what is x? X is 1 over 3 natural log of minus 1.8. So you can easily check that natural log of negative 1.8 does not exist, right? So since natural log of negative does not exist, this implies there is no stationary point for the curve, right? Because when you have some x value, you will get some x coordinate. Substitute over here, you will get the y coordinate. Since you do not get any x coordinate, then there is no y coordinate. So when there are no coordinates, so there is no stationary points, right? I hope this is clear now. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.